How's it going, you guys? And welcome to Unit 5. Unit 5, the last unit of the first semester. So in this unit, really, we're going to be kind of exploring different things about polynomials. So what is a polynomial? A polynomial, poly just means many. So I think that's a Latin thing or something like that. I can't remember. But polynomial just means a many-termed function. We must also have positive whole number exponents. So like if we had 27x to the 7th, or x to the 9th, or x to the 8th, or x to the something, but that exponent has to be a positive whole number. We cannot have like x to the -1 or the square root of x. That's not a polynomial. So it has to have whole number exponents. Monomials are only one term. So they can still look like a polynomial, but they only have one term. So we'll be exploring a little bit of both this unit. The degree refers to the highest exponent of the polynomial. Standard form is written in descending exponential order. Just like we did with our quadratic, we had ax squared plus bx plus c. So the ax to the second, and then it was x to the first, and then it was no x's. So we'll go highest to lowest as we write our things in standard form. The power is the exponent of each term. So we'll talk about that more as we get to it as well. The coefficient is relating to the number in front of the variable. All right, so just looking at this first example here to determine which of the following is a monomial. So this one has 1, 2, 3 terms with it. So that is a polynomial, and more specifically, it's a trinomial. You don't need to say anything else other than that. But here, like with B, it only has one term, so that is a monomial. 7x minus 8 has 2 terms, so it's called a binomial, but it still is a polynomial. It's not a monomial. And part D here also has 3 terms, so that is also a polynomial. Okay, so a monomial just means one term. Unicycle, no. Mono is coming out of one speaker. I can't think of anything else that really relates it to that. Anyways, so example 2, determine the degree of the polynomial and write the equation, or write the polynomial in standard form. So again, do highest exponent to lowest exponent, and that will also tell us the degree of the polynomial. So it looks like the highest exponent here is x to the 5th, so I'll keep all of that together. So 7x to the 5th, I used that. Then the next highest is 6x squared, and it's a positive, so I'll say plus 6x squared. I used that, and then the minus 3x, and then I use that, and then plus 12. There it is in standard form. So highest exponent to lowest exponent, which would be none. Now, for the degree on this thing, the highest exponent is 5. And you'll learn later that the highest exponent actually tells us how many possible zeros we could have. We don't necessarily have to cross the x-axis that many times, but we could cross the x-axis up to 5 times in this one. All right, moving on. With part B, same idea, put it in standard form. So I'm looking for the highest exponent. This time it is to the 13th. So I'll take that term first, 12x to the 13th. So that is done. The next highest I see is plus 7x to the 4th, so plus 7x to the 4th. The next highest is the squared, so plus 3x squared. The next highest is that 9x, so plus 9x. And the next highest is that minus 5. And there it is in standard form. All right, now the power, or the degree, what am I writing? I don't know. Degree would be 13 on this thing. And later on, we're going to be talking about leading coefficient, things like that. What I mean by the coefficient, so the one with the degree 13, the coefficient here is 12. That is called our coefficient. It's just the number in front of the variable. All right, next, the power. So like, sorry, I lost track of what I want to talk about. The power of this term would be 4, and the coefficient, so that's the power, the coefficient would be positive 7. We'll get to more into this later. So actually, we're getting into it now. So determine the coefficient of the term with the power 4. So I am only looking at the one with a power 4. That is my term with a power 4. The coefficient, take the sign with it and everything. So the sign with it is -12. That's it. All right. So simplify the following expressions. So here, combine like terms, just like we did with quadratics. If we have an x squared and an x squared, we can combine them. If we have an x cubed and x cubed, we can combine them. So only combine ones with like exponents. So as I look, and I'll put it in standard form as well. I mean, might as well. We're getting practice putting it in standard form. And that's how you will see it written. So it looks like the highest exponent is 9x to the fourth. There's nothing else. So I'm just going to take 9x to the fourth. Now with our squareds, I have a positive 3x squared and a negative 2x squared. So 3 minus 2 makes plus 1x squared. Oh no, I didn't do the cubes. Okay, all right, well, we're combining like terms. I missed my cube here, so I'll rewrite it in standard form in a second. Minus 7x and minus 7x makes minus 14x, so I used those. And then 12 minus 9 is plus 3. And I still have that plus 6x cubed. So now to put it in standard form, I'm so sorry. I will do x to the fourth first, so 9x to the fourth, and then I have my plus 6x to the third plus x squared minus 14x plus 3. I don't usually write that step in pink there, but I didn't put it in standard form when I was going through, so my bad. But this is standard form, highest exponent to lowest exponent, which would be none in this case. All right, keep going. So still, combine like terms of what we can. Look for your highest exponents first. So it looks like I have an 18x to the fourth, and it's negative, so I'll take my sign with it, and that's negative 18x to the fourth. The next highest is an x to the third, so that's a positive, so plus 7x to the third. The next highest, I don't have any squared, so I go to x to the first, so negative 1/2 and negative 9 would make negative 9.5. X, and then I have 14 and 15, so that's plus 29. There it is in standard form. All right, with the next one. This is called FOIL multiplication sometimes. So FOIL, I hate FOIL, but Apex talks about FOIL. Stands for first, outer, you probably learned this in Algebra 1, inner, and last. I hate it because it only works when you're multiplying two terms, 1, 2, by two terms, 1, 2. It doesn't work when you're multiplying something like part D here. You can't necessarily FOIL that. So I like to just call it distribution. In Apex, they're also going to talk about something called like stack multiplication or something like that. I can't remember what they called it. But what I do, I'll show you first, and then I'll show you that stack multiplication or something like that. It's kind of silly. But what you need to do is all we're doing is distributing the x squared to both terms. So using the distributive property, we're going to do x squared times 3x minus 1. Yeah, that needs to be a minus 1. Oh, I'm so sorry, I cannot write tonight. And then I'm going to multiply this positive 12x to the 3x minus 1 as well. Then I'm essentially just distributing, like I showed there, the x squared to the 3x, so I have 3x to the third, and to the negative 1, so minus x squared. The 12x is also distributing to the 3x minus 1, so I get plus 36x squared minus 12x, and then I'll combine like terms, which are these x squareds in the middle. So I have 3x to the third plus 35x squared minus 12x. That's what we're going to be looking for simplifying the polynomial. Always, always, always put it in standard form if you can. And you can. All right, moving on. So with this one, again, all we're doing is distributing. So here I'll do this distribution, and I won't worry about rewriting. I don't usually take this step right here. I usually just go straight to this because we're just multiplying. So I'm just going to multiply all three things to that x squared. So if I have x squared times x squared, that would give me x to the fourth. Then x squared times 3x would be plus 3x to the third. And then x squared times negative 9 would be negative 9x to the second. Don't forget when you're multiplying x squared times x squared, you're really multiplying four x's together, so you just make it x to the fourth. And then when we do x squared times 3x, we have three x's that we're multiplying together, which is why it's 3x to the third. All right, so then I will distribute the negative 1 to everything. I'll do it in different colors so you know where it came from. So the negative 1 times the x squared would make minus x squared. the negative 1 times the 3x would make minus 3x, and negative 1 times negative 9 gives us plus 9. And then I'm going to go through and combine like terms. So x to the fourth is the only one of its kind, so I'll just say that that is x to the fourth. 3x to the third is the only one of its kind, so I'll say plus 3x to the third. Negative 9x squared and negative x squared make minus 10x squared. Negative 3x is only one of its kind, so negative 3x, and then plus 9. So there it is in standard form. All right, God, I really wish that I knew what they would say. You'll see a weird multiplication. So usually in math, you'll see a multiplication like this. In Apex, this is the first time I've ever seen it like this. They do something like y plus 8, and they do times y to the third minus 7y minus 9. All right, and then they do something like that. So if you see something like this, this really means this multiplication. I can't remember if they called it stack or I don't know why I keep going to that word, but you're just doing multiplication. So really, truly, don't worry about this. If you see that, set it up like this. You're going to see this in pre-cal, calculus, every other math class moving forward. I've never seen that before. I've gone through a math major in college. I've taught pre-calculus for years, so I don't worry about it. Just reset it up. So distribute your y squared to all three terms. So I have y squared times y cubed, which would give me y to the fifth. Y squared times negative 7y, so negative 7y to the third. Y squared times negative 9, so minus 9y to the second. Then I'm going to go through and distribute the negative 6y to all three terms. So negative 6y times y cubed would be negative 6y to the fourth. Negative 6 times negative 7 is plus 42y squared. And negative 6 times negative 9 is positive 54. So plus 54y. I'm going to run out of room. Because then I need to distribute the 8 to all three terms. So I'll do it right below here. So 8 times y cubed would be plus 8y cubed. And then 8 times negative 7 would be negative 56y. And then 8 times 9 is minus 72. All right, so then it's just a matter of going through and combining like terms there. Let's see if I have a different color. I do. I have blue. Blue! I like blue a lot. All right. So I have y to the fifth all by itself, right? No more y to the fifths. Good. So y to the fifth. And then I use that, so I'm going to cross it out so I don't use it again. Negative 6y to the fourth. I don't see any other y to the fourth, so I'm going to say that one is next. Notice I'm going again in exponential order, in power order. So I see negative 7y to the third, and I see plus 8y to the third. So 7 minus, or negative 7 and 8 together make plus y to the third. I used that, and I used that. So I have negative 9y squared plus 42, which gives me to 33, and then no more y squared, so I have plus 33 y squared. Last one, almost. That would be minus 2y, and then minus 72 off by itself. So down there in blue, that's our final answer. That would be the simplified, and it's even in standard form, polynomial. So this last part, I put it because they're going to ask you a question in Apex on the quiz. It's not really super important. Polynomials are closed under addition, subtraction, and multiplication. They're not closed under division. So all that means, the word closed. Closed means if we do this operation, it stays a polynomial. So as you have seen, if I took this polynomial and I subtracted it with this polynomial, it stayed a polynomial. If I took two polynomials and I changed that to addition, that would only change the sign on one thing, but it would stay a polynomial. If I do multiplication of two polynomials, which I've been doing all along, it stays a polynomial. However, if I do a division, which we'll see much later in this section, if I do division, this will not simplify to be a polynomial. The only way this simplifies is if we have common factors in the numerator and denominator, something like this, because then we have this common factor, and then it would stay a polynomial, but it doesn't always. This one does not. This one, there's nothing we can do. Or if you think about x squared over x to the third plus 1. There's nothing we can do there. That one won't simplify either. So just know that that's all that means. All right, hopefully this video was helpful. Please, please, please send me questions, whatever you got, bring it on. I look forward to your emails. All right, see y'all soon.